After 20-plus years of relying on Russia, NASA just achieved what they desperately wanted: complete ISS reboost independence. On September 3rd, SpaceX's Dragon delivered 1.5 times more thrust than Russian Progress vehicles. But there's something bigger happening here that few realize. This breakthrough isn't just about orbital maintenance. It's reshaping space power dynamics and sending shockwaves through Moscow and Beijing. Why did NASA push so hard for this capability now? We'll reveal the strategic implications behind this Dragon upgrade and what it means for America's space dominance. Picture this. Every single month for over 2 decades, the International Space Station has been slowly falling toward Earth. At 400 kilometers up, invisible atmospheric molecules act like microscopic brakes, robbing the 420-ton structure of speed and forcing it into a death spiral that would eventually become catastrophic. And here's what most people don't realize. Only Russia could stop it. Their Progress spacecraft became the ISS's lifeline, docking to push the entire station back to safety using main engines designed for this exact purpose. But America, despite leading the ISS partnership, never had an independent way to perform this absolutely critical operation. We'll come back to why this mattered so much politically. That dependency ended on September 3rd, 2025, in exactly 5 minutes and 12 seconds. SpaceX's Dragon C211 fired its upgraded engines and lifted the station's orbit by 1.6 kilometers. But here's the number that changes everything. Dragon now delivers 1.5 times more thrust than Russia's Progress vehicles. Think of it like replacing a tugboat with a powerboat for moving an aircraft carrier. The engineering challenge was brutal. How do you push a football field-sized structure without breaking the connection point? SpaceX solved it by installing 2 high-powered Draco engines in Dragon's trunk section, completely separate from regular fuel supplies. These aren't typical spacecraft thrusters. They're wrapped in specialized heaters and insulation to survive temperature swings from minus 157 degrees Celsius to plus 121 degrees Celsius. But there's a detail few people appreciate. Unlike Progress vehicles that connect to the Russian segment, Dragon docks to America's Harmony module. This positioning required solving complex physics calculations to ensure thrust wouldn't create structural stress. And here's what's remarkable. NASA's September test showed 0 adverse vibrations, with performance matching simulations perfectly. Why would SpaceX accept the risk of developing this capability when Progress already worked? Because what happened next reveals the true strategic importance. But this is just the beginning. What's really surprising is how this connects to a much larger geopolitical shift that Russia definitely didn't see coming. Here's the context that makes this breakthrough so significant. Imagine if one country controlled every gas station on a critical highway for over a decade. That's essentially what Russia's Reboost monopoly represented in the most important highway in space. And there's something most coverage missed. The timing reveals everything about NASA's true priorities. Since 2014, political tensions made this dependence increasingly uncomfortable. After 2022, when space cooperation faced unprecedented strain, having 0 American backup for such a critical operation became a genuine strategic vulnerability. But here's what few people realize. China has been watching this dependency very carefully while expanding their own Tiangong space station. The economic implications alone justify this development. Previously, ISS reboosts operated entirely on Russia's schedule, tied to Progress missions that might launch months apart. Now NASA can perform altitude maintenance whenever Dragon is docked, which is often since these vehicles remain attached for months. But there's a detail that reveals the bigger picture. This upgrade directly feeds data into NASA's most challenging upcoming mission, the ISS deorbit vehicle planned for 2030 to 2031. Every Dragon reboost is essentially a test run for the most complex controlled deorbit in space history, using the ISS as a proving ground for hardware that will face the ultimate challenge. And here's what's truly noteworthy. Russia and China are watching this demonstration very carefully. SpaceX just proved commercial spacecraft can handle operations once reserved exclusively for government vehicles, in the most critical space infrastructure application possible. Think about what this signals to other spacefaring nations. America no longer needs to negotiate, schedule around, or depend on anyone else for keeping its space assets operational. We'll explore what this means for future space competition. But first, there's a reaction from Russia that most people haven't heard about. And here's why this changes everything about the next decade in space. What happens when the country that controlled a critical space operation for 20+ years suddenly becomes optional? The September Dragon test didn't just demonstrate capability, it announced America's complete operational independence for space station management at exactly the moment multiple nations are building competing orbital outposts. Russia has announced plans for their own space station. China continues expanding Tiangong. NASA prepares for commercial station partnerships in the 2030s. But here's what changes the entire competitive landscape. America now operates the most flexible, powerful spacecraft for critical space infrastructure operations. And here's a question worth considering. Why did NASA push so hard for this capability right now, in 2025? The answer connects to something much larger than ISS maintenance. NASA plans to integrate Dragon reboosts into routine operations throughout 2025, building operational experience while reducing wear on Russian systems. This creates practical redundancy that hasn't existed since 1998. But more importantly, it establishes precedent for American spacecraft handling the most demanding space operations independently. But there's a challenge most people don't consider. Dragon's 1.5 times higher thrust means developing entirely new operational procedures for optimal reboost scheduling. Different orbital mechanics require different thrust patterns, and NASA must integrate this capability into decades-established ISS protocols while the clock ticks toward 2030. What's the real long-term impact? As NASA develops Lunar Gateway and eventual Mars missions, the experience gained from operating commercial vehicles for critical space infrastructure becomes invaluable. Dragon's reboost capability represents the first step toward commercial spacecraft, assuming roles that will define space exploration leadership. Yet here's what remains uncertain, and why Russia should be concerned. Will they continue progress operations alongside Dragon, or focus resources on their planned independent station? How will China respond to America's enhanced operational freedom? And most importantly for the next decade, what other critical space operations might American commercial vehicles assume? Here's what we know for certain. September 3rd, 2025 ended more than just America's dependence on foreign reboost systems. Dragon didn't just push the space station higher, it elevated the entire trajectory of American space dominance into an era where NASA no longer needs to ask permission, negotiate schedules, or depend on anyone else for the most critical space operations. That's the kind of independence that reshapes everything. This is exactly why NASA fought so hard for Dragon's reboost capability. It wasn't about routine maintenance. What this means is America just eliminated its last critical dependence in space operations, positioning itself as the only nation capable of complete space station independence as we enter the era of competing orbital outposts. Think about the bigger picture here. Every Dragon reboost builds experience for Lunar Gateway operations, Mars missions, and the complex spacecraft systems that will define human expansion beyond Earth. Russia's two-decade monopoly didn't just end, it shifted to a country rapidly advancing toward multiplanetary capabilities. And this is just the beginning. NASA plans multiple Dragon reboosts throughout 2025, while SpaceX continues upgrading commercial spacecraft for increasingly complex operations. By 2030, when the ISS deorbit mission begins, we'll witness the most challenging controlled re-entry in space history using systems proven through these exact tests. But here's what I'm curious about. How do you think China and Russia will respond to America's complete operational independence? Will this accelerate their own space station development or force new international partnerships? This is Space Hub, and we dive deep into the breakthroughs reshaping human spaceflight. If analysis like this helps you understand what's really happening beyond the headlines, you know what to do. Because September 3rd didn't just raise the ISS 1.6 kilometers higher, it elevated America's space program into an era where the only limits are the ones we choose to accept.